All right. Page 229, number 7. I did a terrible job of trying to explain this in class. So I'll see if I can clear this up. A rope pulls a 2-kilogram bucket, mass equals 2, straight up, accelerating from rest at 2.2 meters per second. So acceleration equals 2.2, and that's up for 3 seconds. Time equals 3. So part A, calculate the displacement. We have that already. Calculate the work done by each force acting on the bucket. You've got a rope and you've got gravity. So there's 2 parts to this question here. So if we start with gravity, doesn't matter which one you start with, gravity, the work that it's doing, work equals force times displacement. Force is mass times its gravity, so it's mg d, mgd. I have someone knocking at my door. Give me 1 second. Come in. Okay, sorry about that. Where are we? So work equals force times displacement, which is mass, gravity, displacement. Now gravity, so this bucket, it's a bucket, I think, I don't remember, but it's going up. Gravity is pulling on it, but gravity is losing, right? So remember, like my tug of war example, there's stuff going on, but gravity is losing. So the mass is 2, gravity is 9.8, and the displacement is 9.9. The displacement, sorry, is negative because it's the opposite direction to the direction gravity is going. So this 2 times 9.8 times 9.9, 194. 194. So with sig figs, it's, and it's going to be negative 190 joules. Well, maybe I'll come back to that after I talk about the rope. So now the rope, and this is what I screwed up on in class, the rope has to overcome gravity. Oops, it's a leaky pen. The rope has to overcome what gravity is doing. So for the rope, you say it like the rope is a person. Work equals force times displacement. Force is mass times acceleration times displacement. So now it's mad. But the acceleration here, if the acceleration of just the rope, like of just the rope, not the net, just the rope, if it was 9.8, that means that that bucket would not be moving because 9.8 up, 9.8 down. But it's actually moving 2.2 meters per second up. So it has to first compensate for that 9.8. So what this will look like, the mass is 2, the acceleration is 2.2 plus 9.8, and then the displacement is 9.9. So this 2 times 12 times 9.9, 237.6. 237.6, which is going to be 240 joules to the positive. This was the part I did poorly on today when I was trying to explain it. I hope that makes sense. I can come back to this as many times or as much as you want. Sorry for the lack of clarity. So one way to think of this is if that bucket's not moving, you know, the work is going to be 0 by both, but gravity is still at 9.8. Which means that the rope has to be doing 9.8 up so that it's not moving. It has to counter that gravity. And so because measured net is only 2.2, it means kind of behind the scenes, it's also doing this. If I push on the wall, it doesn't move, it's 0. If I'm like with 400 newtons of force, nothing. If I push with 401 newtons of force, I'm actually pushing against the walls if you guys can see me right now. If I'm pushing with 401 newtons of force, and that's what causes the wall to start moving, it's going to start moving slow, theoretically. That 400 was countered by the wall. Now it's kind of that extra newton that's pushing it over the edge. I hope that makes sense. If it doesn't, like I said, I'm happy to revisit this multiple times. Sorry about the confusion I may have caused, probably caused earlier.